Every time your computer feels instant, a tiny chip is sprinting through a mountain of instructions you never see. You click an icon, a window opens, a video starts, a file saves, and it all feels almost effortless. But nothing inside a computer is effortless. That feeling of speed comes from a CPU doing an absurd amount of work in the background, so fast that the machine starts to seem alive. And that is the first trap. The CPU is often called the brain of the computer, but that makes it sound like it understands what is happening. It does not. It follows instructions at unbelievable speed, and that difference is everything. A CPU is basically an instruction engine. It receives tiny commands, processes them, and moves to the next one over and over again. It is not thinking in the human sense. It is not deciding what a browser should do or what a game means. It is taking operations one by one and executing them with brutal precision. That is how a computer becomes useful, not because the CPU is intelligent, but because it is relentless. The more efficiently it runs through instructions, the more alive the whole system feels from the outside. And this is where the story gets more interesting. The CPU does not work alone, and it definitely does not work in peace. It has to keep asking for data, waiting for data, processing data, and then asking for more. Every app, every tab, every game, every background process is part of that demand. So the processor is constantly moving between tasks, never resting in the way people imagine. It looks smooth on the screen, but underneath, the CPU is handling a non-stop flood of tiny jobs, each one demanding attention. If you like seeing how these hidden systems really work, this is exactly the kind of thing we break down here. The stuff people use every day is usually the stuff they understand least, and that's where the real story lives. The CPU works in a repeated cycle. It fetches an instruction, decodes it, executes it, then moves on to the next one. That cycle happens so quickly that it disappears into the user experience. You don't see the instruction stream, you only see the result. A folder opens, a browser loads, a game reacts, a calculation appears instantly. But behind every one of those moments is a processor burning through tasks, one after another, trying to keep the entire computer responsive. The strange part is that a CPU can be extremely fast and still feel slow if the rest of the system is dragging it down. That's because the processor is not the only thing that matters. It needs memory to hand over data quickly. It needs storage to feed programs into memory. It needs the whole system around it to stay coordinated. If any of that becomes sluggish, the CPU ends up waiting, and waiting is wasted power. A fast chip sitting idle is still a chip sitting idle.
That is why people often misunderstand performance. They assume speed comes only from raw CPU power. Sometimes that is true, but not always. A computer feels fast when the CPU, memory, and storage all work together without slowing each other down. When that balance breaks, the whole machine feels heavier, even if the processor itself is capable of much more. So a lot of what people call good performance is really just good coordination. The CPU also has to juggle multiple tasks at once. A browser might be open, music might be playing, a game might be loading, and background processes might be checking for updates. It looks like all of that is happening at the same time, and in practical terms, that is how it feels. But underneath, the CPU is rapidly switching attention from one job to another so fast that the switching itself becomes invisible. That is part of what makes modern computers feel responsive. The processor is not calmly doing one thing, it is constantly managing pressure. And that's the real trick. The CPU is powerful not because it does one huge task, but because it can keep doing tiny tasks at a ridiculous pace without losing the thread. It turns instruction after instruction into the illusion of smooth, intelligent behavior. That is why your computer feels like it knows what it is doing, even though the chip at the center of it is just following rules. The better the CPU gets, the less you notice it. That's the strange reward for good engineering. The computer feels natural, immediate, and almost invisible, while the chip underneath is doing enormous amounts of work to make that feeling possible. So when people call the CPU the brain of the computer, they're only half right. It's more accurate to call it the engine that keeps the whole machine moving fast enough to feel smart. And that's the CPU in plain terms. Not a thinker, not a mind, not a little metal genius, just an incredibly fast instruction machine turning code into action one step at a time. The next time your computer opens something instantly, remember that a tiny chip just ran through a chain of instructions so quickly you never even noticed it was there.